Welcome to the Deal of Today. We're going to talk about a really fascinating new AI model called CLaRa, and its goal is a big one: to teach AI how to think before it even starts searching. This could solve one of the most frustrating problems we see in AI today. So I bet you've run into this, right? You ask one of these super smart AIs a question, and what you get back is, well, it's just confidently wrong, or sometimes it just makes things up entirely. Even the biggest, most powerful large language models, LLMs, they all do this. So the big question is, why? Okay, so the heart of the problem, it really just comes down to memory. See, an LLM's brain is basically frozen in time. All its knowledge is from the day its training finished. It can't just, pop open a browser and Google something in real time. And that static, unchanging knowledge, well, that's its Achilles heel. And this weakness, it leads to two huge flaws that you've probably seen firsthand. First, there's what researchers call hallucination, which is just a fancy way of saying it makes stuff up when it gets stuck. And then there's knowledge obsolescence. That's when the AI gives you an answer that was totally right, like a year ago, but now it's just completely out of date. So for a while now, the go-to solution for this has been this really clever workaround called Retrieval-Augmented Generation. You'll hear it called RAG, and the whole point of RAG is to give these AIs a lifeline to fresh, external information. Now, the idea behind RAG is actually pretty simple, but it's really powerful. Think of it like a two-step dance. First, you have a retriever. Its job is to go search through an external database, could be a chunk of the internet, could be a company's private files, and find anything relevant to what you asked. Then it hands all that info over to the LLM, which we call the generator, so it can write you a nice, accurate, up-to-date answer. Yeah, the best way to picture it is like giving the AI an open book exam. Instead of forcing it to rely on what it crammed for months or years ago, you're giving it a cheat sheet with all the latest info right before the test. Simple, right? But here's the catch. It turns out this open book exam has a really big hidden flaw. So, this whole open book idea has a major disconnect built right into its core. And to really get it, let's use an analogy. Let's imagine the two main parts of a RAG system are two different people just trying to get a job done together. All right, so on one side, you've got the librarian. This is our retriever. Its job is to sprint through the library stacks and just grab any and all books that look like they might be relevant. It's super fast, but it's also very, very literal. Then, on the other side, you've got the writer. This is our brilliant LLM, the generator. Its job is to take that pile of books and craft a beautiful, coherent story, which is, the final answer. And here is where it all goes wrong. The librarian and the writer, they don't actually talk to each other. Not really. The librarian just finds a bunch of books based on some keywords and plops them on the writer's desk. Then, the writer has to sort through this giant pile, but has absolutely no way to tell the librarian, hey, that third book? Total garbage. But that one paragraph in the first book? That was pure gold. Get me more stuff like that next time. See? There's zero feedback. So this broken system, what researchers call a disjoint design, it creates two massive problems. First, there's no optimization. The librarian never gets any better at its job because the writer can't give it any pointers. The feedback loop is just broken. And second, it's super inefficient. The librarian and the writer basically speak different languages. One thinks in these abstract mathematical concepts, the other has to read every single word of text. It's a huge communication breakdown, and it wastes a ton of effort. And this is exactly where CLaRa steps in. It's a really elegant solution that's designed to finally get the librarian and the writer to work together, on the same page, as one unified team. What CLaRa does is create this unified system where both finding the info and writing the answer happen in the same shared space. It's like it finally teaches the librarian and the writer to speak the same language, closing that massive communication gap for good. The secret sauce here is something called shared continuous representations. It sounds complicated, but the idea is brilliant. Instead of the librarian handing over entire bulky books, CLaRa compresses every single document into these tiny, compact memory tokens. It's like creating a super condensed, information-packed summary that both the librarian and the writer can understand in an instant. So here's how it actually works. First, CLaRa compresses all the documents into that shared language of memory tokens. Then, when your question comes in, this new piece called a query reasoner actually thinks about your question. It tries to figure out hidden clues. After that, the librarian and the writer work together using that super efficient compressed info. And here's the most important part. At the very end, the writer's performance on the final answer gives direct feedback to the librarian, so the librarian actually learns and gets better for the next time. That broken feedback loop, it's finally fixed. Okay, so that all sounds great in theory, but does it actually work in practice? Well, the results are pretty darn impressive. CLaRa is able to move way beyond just matching keywords. It actually starts to reason about what kind of information is really needed to answer a tricky question. Let's look at a real example from the research paper. A user asks this really complex, multi-part question. How many yards did the nephew of Ivory Lee Brown get during his 2004 true freshman season? Okay, so a normal search would just grab the keywords Ivory Lee Brown and nephew and probably fail. But CLaRa's query reasoner is way smarter. It thinks about the question and adds related concepts that aren't even there, like NFL, Oklahoma, and even the name of the nephew, which is Adrian Peterson. So by reasoning about the intent, what the user is really asking, CLaRa can find these crucial connecting documents that a dumb literal keyword search would have missed a mile away. And for answering these complex multi-hop questions, that is an absolute game changer. But let's talk numbers. What does this all mean for performance? Well, the improvement isn't just small, it's pretty significant. We're talking about a more than 10% jump in retrieval accuracy. On a benchmark, that is notoriously difficult. And what's really incredible here is that it beats models that were trained on tons of expensive, hand-labeled data. CLaRa teaches itself to be better just by doing the task. No extra homework needed. So you can see this isn't just some minor tweak. CLaRa's whole unified approach is really pointing the way to a brand new future for how AI memory and reasoning could work. So let's break down why this matters so much. First, CLaRa creates true collaboration inside the AI's brain. Second, it's way more efficient because everyone's speaking the same compressed language. Third, it actually gets smarter over time thanks to that natural feedback loop. And maybe most importantly, this is a huge stepping stone towards AI agents that can manage their own memories to tackle really, really complex problems on their own. And that leaves us with one last big thought to chew on. We've just seen how teaching an AI to think before it searches can completely change the game. So here's the question. If an AI can learn to build and reason over its own super efficient, compressed memories, what does that really mean for the future of thinking machines?